Suppose A and B are the position vectors of the point 1, -1 and -2, m. Determine the value of m for which A and B are collinear. Okay, let us begin. So let's say we have 2 points, point A and point B. The coordinates of point A are 1, -1 and coordinates of point B are -2, m. We'll consider a point O, which is going to be the origin of a two-dimensional coordinate system. With respect to this origin O, we can define the position vector of point A and point B. All we have to do is join O and A with the help of a directed line segment. Similarly, we will join O and B with the help of another directed line segment. Now, we can define the position vector of point A as the vector going from O to A. This is given by what we have to do. We have to consider the coordinates of the origin. So it is 0, 0. Now to define OA vector, we have to take the difference of the x coordinate. So we take 1 minus 0 and multiply it with I cap, indicating that this is the component along x direction. Added to, now we'll take the difference of the y coordinate. So we'll take -1 and from it subtract 0. So -1 minus 0, j cap. Simplifying this gives us I cap minus j cap. So this is the position vector of point O. However, point A. However, in the problem, it's already given that the position vector of point A with coordinates 1, -1 is A vector. So in other words, A vector is I cap minus j cap. Similarly, we can define the position vector of point B. So position vector of point B, which is OB vector, and according to the problem, it's actually B vector. This is given by -2 I cap plus m times j cap. Fine. Now, it's given here that the vectors A and B are collinear. Now, since A vector and B vector, it's already given that these vectors are collinear. If they are collinear, this means only one thing. This could mean that we can express the vector A as some scalar lambda times the vector B. Well, we have to mention where lambda is some scalar. Fine. Now, what we'll do? We will use the value of A vector and B vector. So A vector is I cap minus j cap. This is going to be equals to lambda times B vector. So that's -2 I cap plus m times j cap. So we have I cap minus j cap. So we equals to -2 lambda I cap plus m lambda j cap. Fine. Now what we'll do? We'll transpose the two terms from the right hand side to the left hand side and combine all the like terms. So that's going to give us 1 plus 2 lambda. So this gets multiplied to I cap. And then we have -1 minus m lambda all multiplied to j cap. This is going to be equals to the null vector. So we have to be careful here. This has to be a null vector because on the left hand side we're operating with vectors. So vector operations must give us a null vector only and nothing else. However, we know for a fact that I cap and j cap are non-collinear vectors. Now, why they are non-collinear? Because they are always orthogonal to each other. They're perpendicular to each other. Hence, they cannot be collinear. So, they are non-collinear. Now, if they're non-collinear, then this particular equation is going to be true only when 1 plus 2 lambda, that is the coefficient of I cap, or you can say component of I cap, that's going to be equals to 0, and simultaneously -1 minus m lambda, that's also equals to 0. Okay. Now, when we solve for lambda comes out to be equals to -1/2, and we will use this value to find out the value of m. So here we have m lambda. This is going to be equals to -1. So m comes out to be equals to -1 over lambda. So substituting lambda with -1/2, so that gives us +2. So that means the value of m comes out to be equals to 2, provided the point 1, -1 and -2, for m, which is defined by the position vector A and B, are collinear.